Mystery boxes is a really great hands-on activity that's really memorable for students, and it really helps them get to grips with some of the key ideas about how scientists work and how they come up with theories and ideas. The object of the activity is to work out what's inside a set of 6 mystery boxes without opening them. The activity begins by dividing up your class into small groups of about 3 or 4 students per group. Each group then receives an observation grid with post-it notes on and a mystery box, and they have to come up with their best idea about what's inside the box.
Group 5, Lewis, and Group 6, Matt.
You're then going to give them 2 or 3 minutes with each box to try and work out their best idea about what they think's inside.
I reckon it's quite small, because it would feel a lot heavier, wouldn't it? Write it down then. So we put small.
It's really important that your students write down lots of observations while they're testing out and examining the boxes. When you stage a mock science conference later on in the activity, they're going to need those observations to form their evidence to help back up their ideas and argue their point.
Yeah, put down blue tack. Blue tack. Yeah. Blue tack? What do you think then? It kind of does stick. Think about it. It's not blue tack. Blue tack will make a noise like that.
So once the 2 minutes is up, students need to write down their best idea on the post-it note before they pass the box on to the next group.
Does everyone come to a decision?
Wooden, rectangle.
Wooden shape, it's a wooden shape. It narrows it all down.
Can the runners please take the box to the next group? So 1 is going to go to 2, 2 is going to go to 3, 3 is going to go run like the wind. 5, 5, yeah.
Once all the boxes have been passed around, everyone should have 6 sets of observations and 6 best ideas about what they think is inside the boxes. But before they're going to see each other's ideas, it's important for the students to think about what they've just been doing. So give the students 2 minutes to discuss what skills and approaches they think they've been using to get to their best ideas.
Down, senses, hearing.
Listen to the pitch to find out the density, how much kinetic energy.
You say frequency as well, because then it'll like prove if it's bouncy or not.
Get them to write down a short list, and once they've done that, share that back with the class.
Communication skills, our senses, and our estimation skills.
Did you say estimation?
Yeah. Like you have to estimate the weight of it.
Okay, good, excellent. Brilliant.
What you need to point out to your students that what they're looking at is actually what we recognise as a scientific process. So it'll have all the elements that they're quite familiar with, making a prediction, testing that out, and coming to a conclusion. But it also includes things that students are less aware of. Creativity, imagination, and visualisation are all an important part of the scientific process. And also the idea of discussion, and that science is very social. So after the reflection time, it's time to get your students 1 step closer to working out what's inside the mystery boxes by staging a mock science conference. And 1 student from each group needs to bring their post-it notes with their best ideas up to the front and to stick them into the relevant box on a large grid. So now you need to take a look at the grid to find a couple of different examples where people either agree or disagree. Firstly, have a look and see if you can find a box where most people have very similar or the same answers. And you can point out that they could feel quite comfortable that this was now a leading idea or a leading theory, and without opening the box they can all feel reasonably certain that their research was correct.
Box 1, all of you have come up with the fact that it's a ball. Some people have said it's a rubber or bouncy ball. Okay, pretty much the same thing. Okay, so you've got consensus there. Everyone has agreed.
It's also good to pick out another example where there's a lot of contrast, and then you can get the groups to present their evidence to each other and try and convince each other that their idea is more correct than the other groups. And you can also give groups the opportunity to change their mind if something they've heard has shed new evidence on their ideas.
I think if it was soil and sand, it wouldn't have sort of rattled as much. Also, it would have sort of shaken around a lot more and been a lot heavier. Because we thought it was a beanbag because it did rattle with like the beans inside of it.
I disagree with you, Alex, because a beanbag has bigger balls in it, and when it hits the top, it would make a bigger sound than soil does.
During the conference, it's good to point out to your students that what they've been doing is working just like scientists and having their research peer-reviewed. So to draw the activity to a conclusion, you need to reveal to the students that they're not going to find out what's inside the boxes.
Is there any questions?
Yeah. What was in the box?
I don't know. Okay. And you guys can't find out.
Hopefully by now they'll realise that the boxes are an analogy for science. And just as scientists can't open the box and find out the answers, neither can they. And that's one of the things that really drives scientists to do their research.
I really enjoy running the activity because it brings another side to the pupils. They actually learn without you having to teach them. I think that's the key. They discuss them, they become much more focused and energised by the activity.
I like the fact it was all hands-on, a lot more practical, and that everyone got a say in what they thought was in the box, their own opinions, their own views. And when we came together at the end to discuss them, I thought that was quite good.
First of all, when the teacher said it wasn't allowed to open the boxes, I was a bit disappointed because we'd all tried very hard to try and find what was in the box, and then we'd known that we wouldn't actually find out for definite. But then when you think about it, that's what the scientists have. They never know the definite answer. They can only go by the hypothesis.